Assalamu alaikum. This is chemistry 12th and our today's lecture. It is about the reactions of aldehydes and ketones. Actually, we are going to discuss in our today's lecture. We are going to discuss these nucleophilic addition reactions of these carbonyl compounds. Now, as far as the reactions, chemical reactions of these aldehydes and these ketones or the carbonyl compounds are concerned, they show different types of these reactions. We have got nucleophilic addition reactions. We have got nucleophilic addition reactions followed by elimination of water molecule. Then we have got the oxidation reactions. Then we have got the reduction reactions, and we have got some miscellaneous reactions of these aldehydes. Now, in our today's this lecture, we were going to discuss the nucleophilic addition reactions of these carbonyl compounds. Now, as I have already told you about this, carbonyl, the nature of the carbonyl group, the carbon. The oxygen, because of its high electronegativity, attracts the shear pair of electrons slightly towards itself, as a result of which it develops a slight negative charge, while the oxygen atom it develops while as the carbon atom while the carbon atom it becomes positively charged. Now, as a result of this positively charged positive, the presence of this positive charge on this carbon atom of this carbonyl group, these carbonyl compounds are they are attacked by the nucleophiles easily, so they undergo nucleophilic addition reaction. So some of these nucleophilic addition reactions of these carbonyl compounds are the first reaction I would like to tell you here. This is addition of this sodium bisulfite. Now, sodium bisulfite, that is NaH SO3, sodium bisulfide. Now, as far as this reaction is concerned, both aldehydes and ketones, they form these crystalline addition compounds, which we call as bisulfide additives, when they are treated with a saturated this solution of sodium this bisulfide. For example, you can see here, this is acetaldehyde I have shown here, and it reacts with this sodium this bisulfide, and we get this the addition product we get here, that is ethanol sodium bisulfide. The initial attack involves the attack of this bisulfite, this ion or anion, because it being negatively charged, this is a nucleophile, and it attacks this carbon of this carbonyl group. You can see here the initial attack, this is carbonyl, it attacks this and this is the carbonyl. You can see there is polarization of this C double bond O bond. Now, this nucleophile, that is the bisulfite, this ion, it will attack this carbon, and it will give rise to a negatively charged this anion, and then there is a proton transfer, you can see here, and we get this proton, as it attacks the oxygen, then we see then it reacts with this sodium ion, and to form the final this addition product. Now, as I have told you that the reaction involves the nucleophilic addition of this is bisulfide ion, I have told you, and on this polarized carbonyl carbon, and this is followed by the proton transfer. I have shown here how proton transfer takes place, and then it combines with this sodium ion to give the final product. Now, as far as this reaction is concerned, the bisulfide addition product of aldehydes and ketones, as I have told you, they are the crystalline salts, and as this reaction is reversible, the addition product can be decomposed by mineral acids, or it can be decomposed by an aqueous alkali to give back the original aldehyde or ketone. Therefore, this reaction is used in the purification and in the separation of aldehydes and ketones from other compounds, that is non-carbonyl compounds. Now, then we have got the other reaction, that is the addition of this hydrogen cyanide, HCN. Now, as far as this reaction is concerned, we see that in this reaction cyanohydrogens are formed. Now, both aldehydes and ketones, I have shown here ethanol, react with hydrogen cyanide to form the addition product, as I have shown it. This is a cyanohydrin. So this reaction is generally carried out in presence of a base that picks up a proton from this HCN to generate this nucleophile, and this that is Cn minus. Now this cyanide ion, then it attacks the carbon of this carbonyl carbon to give this to give this final product, that is cyanohydrin. So this is this base, this is used as a catalyst, and as I have told you that it removes a proton from the hydrogen cyanide, generating the nucleophile, and which then attacks this carbon of this carbonyl carbon. Then we have got one more reaction, that is the addition of a Grignard's reagent. Now, as far as this Grignard's reagent is concerned, what we see in this case, these aldehydes and aldehydes, they give rise to the formation of alcohols. Now you can see this is a Grignard's reagent. This is I have shown here, this is formaldehyde. Now, as far as formaldehyde is concerned, this on reaction with this Grignard's reagent, it gives primary alcohols. Then we have got these the other aldehydes other than this formaldehyde, they give secondary alcohols, and ketones, they give rise to the formation of these tertiary alcohols. Now you can see here, I have shown here, this is formaldehyde. So now the attacking the attacking reagent in it is a carbanion. This is carbanion, which is generated from this Grignard's reagent, and this attacks this carbon of this carbonyl carbon, and it gives rise to the formation of an addition product. And this addition product which is formed, and this upon hydrolysis gives us you can see here, this gives us the alcohol, plus we get this hydroxy magnesium chloride. I have shown here, this is methyl magnesium chloride, and this is formaldehyde, and this is addition product, and we get this is ethanol. This is a primary alcohol, and then we get plus this hydroxy magnesium chloride. Now if we use other aldehyde instead of formaldehyde, we can use acetaldehyde. Now again, in this case, the product formed it would be a secondary alcohol. You can see here, this is a secondary alcohol, or it is known as propantool. That is a secondary alcohol, and plus this is hydroxy magnesium chloride. Now instead of this acetaldehyde, or we can also use a ketone. If we use ketone, then the product obtained is a tertiary alcohol. So this the reaction of these aldehydes and ketones with this Grignard's reagent, that this reaction is used for the preparation of primary, secondary, and tertiary alcohols, depending upon the nature of the aldehyde used. As I have already told you, that formaldehyde, it gives us a primary alcohol. Then we get if we use other aldehyde, then we get secondary alcohol, and if we use ketones, then in that case we get a tertiary alcohol. Then so this is the addition of this Grignard's reagent. Then then other reaction is the addition of the alcohols. So as far as this addition of alcohols is concerned, this reaction is used for. In this reaction we get acetals are formed. Actually, the reaction takes place in two steps. During one step, in first step, we get this first hemiacetals are formed, which then react with one more molecule of this alcohol to give rise to the formation of these acetals. Now both these aldehydes and ketones, they react with these alcohols in presence of this dry HCl to give gym dialloxy compounds. You can see gym means when the two allox groups are attached to the same carbon atom. The compounds, they are called as the acetals. Now the reaction, as I have told you, takes place in two steps. In first step, the addition of one molecule of alcohol to an aldehyde gives an hemiacetal. You can see first how this first step involves this alcohol. It reacts with this aldehyde molecule, and we get a hemiacetal. Now the hemiacetal, it contains both an ether and an alcohol functional group. You can see there in this case we have got this is ether language. This ether this is ether this linkage here, and plus we have got this hydroxyl group also. So now since it is unstable, this hemiacetal, it is unstable, and it reacts with one more molecule of alcohol to form the acetals. You can see here. So in first step, upon reaction of these aldehydes with alcohol molecule in presence of dry cell, we get first hemiacetals containing two these functional group. You have got this is ether group, and then we have got this is the hydroxyl group. So two functional groups are there. So it being unstable reacts with one more molecule of this alcohol to form the acetals. I have shown here this is ethanol. First how the attack takes place. You can see that how this hemiacetal is formed, then it reacts with one more molecule, and then forming the acetal. Now, as far as this reaction is concerned, the reaction, since it is a reversible reaction, since it is a reversible reaction, so acetals formed can be decomposed. They can be decomposed by mineral these dilute mineral acids to give back this original aldehyde. You can see this is a influence of a mineral acid. With these acetals, they are decomposed again to give back this original aldehyde. Now instead of these if we use if we use this alcohols, now if we use hydric alcohols, that is diols, if we use this is I have used this is ethanol or acetaldehyde. When it reacts with this diol, this is ethylene glycol. So it forms cyclic this acetal. Similarly, when ketones are treated with this dihydric alcohols, they give rise to the cyclic ketones. Now these are some of these nucleophilic addition reactions of these carbonyl compounds, or these aldehydes and ketones. Now if I will show you the mechanism of these reactions separately, it will take me one lecture for each reaction to show its mechanism. So since time is very limited, so I can't go in detail through these reactions. So this is for today. Thank you very much.